Hello everyone, welcome to today's class. This is teacher Simon taking you through Cambridge International AS and A-Level Mathematics paper 5-1 for May June 2024 for questions from 5 to 7. Question 5. In a certain area in the Arctic, the probability that it snows on any given day is 0.7 independent of all other days. So when they say that independent of all other days, that implies that it can either be a binomial or a geometric. Okay. Then part A, find the probability that in a week, those are 7 days, it snows on at least 5 days. So now since n is known, then that means that it is a binomial. Okay, n is fixed, it's a binomial. Now, our p is 0.7, our q is 0.3. Okay, now probability of x greater or equal to 5 at least means greater or equal. That means I will get probability of x is equal to 5, then plus probability of x is equal to 6, and then I will also get probability of x which is equal to 7. Then this one is going to be for the binomial, I'll have 7 which is our n. Okay, then combination 5, then our p is 0.7, then we put power 5 because successes are appearing 5 times, and then 0.3, then power 2. Remember, when you get this plus this, it gives you the n. Okay, and then plus here 7 combination 6, then 0.7 to the power of 6, and then 0.3 power 1, then plus 7 combination 7, then 0.7 power 7, and of course 0.3 here power 0. So when we put this in the calculator, what do we get? There are 4. We have 7 combination 5, then times 0.7 power 5, then times 0.3 power 2. Okay, power 2. Then I'm just going to add on another one. I'm going to do it all together. 7 combination 6, then times 0.7 power 6, then times 0.3 which is power 1, then plus 7 combination 7 which is a 1, then times 0.7 power 7. Then I won't put the other 0.3 power 0 because it is a 1. Okay, so all together that is what I get, but the 3 significant figures I will write 0.647. 0.647, the 3 significant figures. They are saying a week in which it snows on at least 5 days out of the 7 is called a white week. Find the probability that in 3 randomly chosen weeks, at least one is a white week. Now our p here has changed. Okay, so here the n is again 3. The n is 3, and then at least means greater or equal. So my new p here is going to be this one here. They say that a week in which it snows on at least 5 days, which we have gotten here, snows on at least 5 days. You see here. So meaning our p is actually this one. When you look at this one here, I'm going to take 4 decimal places. Okay, 0.6471. This one is 0.6471. then Q is 1 minus that, right? 1 minus the answer. That is 3529. 0.3529. Then probability of our x greater or equal to 1, at least. Okay, so it means I can have for x is equal to 1, 2, and 3. Okay, but it is the same as just saying probability of 1 minus x is equal to 0. Okay, because we have 0, 1, 2, 3. But then if I need for probability of x is equal to 1, 2, and 3, and then 0 is left out, so I just say 1 minus probability of x is equal to 0. Then I will have 1 minus, this will be now 3 combination 0, and then 0.6471 power 0, and then 0.3529 power 3. Then what do we get when we put in the calculator? We are going to say 1 minus, can put in brackets 3 combination 0, then times, I think I'm just going to say 0.3529 power 3, because the other one is power 0, which is a 1. So this is what we get, but to 3 significant figures, I will say 0.956. 0.956 to 3 significant figures. That is that. In a different area in the attic, the probability that a week is a white week is 0.8. Use a suitable approximation to find the probability that in 6 randomly chosen weeks, fewer than 47 are white weeks. The moment you see this suitable approximation, then we are moving away from binomial and we are going to normal. Because if they say in 60 randomly chosen weeks, yes, then n is known, so it is a binomial. But then fewer than 47, you are having something like this, fewer than 47. So are you going to have probability of x is equal to 46, okay, 45, 43, 42, and all of those up to 0? No, it becomes hectic. So that's why we approximate the normal to the binomial. So we are going to have p, which is equal to 0.8, and then our q is going to be 0.2. Then our n is what? 60. So when we are approximating to the binomial, we look for the mean, okay? But the mean we use here is the one for the binomial. When we are approximating to the normal, we look for the mean. But the mean we use is the one for the normal, okay? So mean is equal to NP. For the binomial, I mean for the normal distribution, you must know the mean, you must be having the mean and the standard deviation. So NP, this one is going to be 60 times 0.8, which is going to give us 48. And then we need the standard deviation, which is equal to square root of NPQ. And this one is going to be the square root of 60 times 0.8 times 0.2. Okay, so 48 times 0.2, that one will give us 9.6. Okay, so you can leave it there like that. And then next, by the way, they can ask for the justification of this approximation. You have to say NP, you have to find NP and NQ. So NP is, we have said 80 times 0.8, which is 48. And then NQ will be, I mean, this is 60, not 80. It's like I've said 80. So then 60 times 0.2, which is equal to 12. Okay. Now, both of these are greater than 5. So since they are greater than 5, then the approximation is valid. Okay. Now, and before we do anything else here, we need to do what we call continuity corrections. So in O level, Now in IGCSE, you did what we call upper and lower bounds. So I have the number 47 and I have here 48. Then I have the number here 46. Okay. Now here I have 47.5, that is the upper bound. And then here I have 46.5, because this is where 45 begins from and this is where it ends. Okay. Now this is the region for this 47. Now if we are looking for probability of x which is less than 47, okay, this one, first of all, we are going to standardize probability of z less than, we are going to get that x, okay, then we subtract mean we have gotten as 48, then we divide by the standard deviation, which is root of 9.6, like that. Now we want to get the numbers. We either use this one or this one, but how do you know which one to use? That when you round off, get numbers that when you round off, okay, what you get is always less than 47. Okay, what you get is less than 47. So it will be here that when I get numbers below this one, below it, when I round them off, I'll get a number below 47. Okay, below this one, I will get a number below 47, because 47 for it begins from here and then it goes this other side. So meaning I will get my answer here as 46.5. 46.5. In other words, subtract a. So I always give this one here. For greater than, you add a 0.5. For less than, you subtract a 0.5. And then for greater than, do the reverse. That will be subtract 0.5. And then for less than or equal, this one is for greater than or equal, and then this one is for less than or equal, you add a 0.5. So this one here. All right, then I can put this in the calculator and I get my answer right away. Okay, or you can use the table, but this one I can get it right away. So probability of z less than, this one will be negative 1.5, then divide by the square root of 9.6. So using the calculator, this is what we get. I said you can press mode, then start is 3. Then from there you can press SC, then press shift, then 1, then press 5. Where there is distribution, press 5. Then since this one is for less than, I can press 1, and then I can put that negative 1.5. Okay, then I divide by that square root of 9.6. Okay, then close the brackets. So the answer is 0.31415, and to three significant figures I can write it as 0.314. But this one will be 0.314. Three significant figures, like that. Question 6. Harry has 3 coins. One coin is biased so that the probability of obtaining a head when it is thrown is a third. The second coin is biased so that the probability of obtaining a head when it is thrown is 1/4, and the third coin is biased so that the probability of obtaining a head when it is thrown is 1/5. Harry throws the 3 coins. The random variable x is the number of heads that he obtains. Draw up the probability distribution table. Now, I can actually first draw the tree diagram just to show you what is happening here. So I can have, this is head and then tail, because those are the possible outcomes when you throw a head, a coin. So we have also here head and then tail. Then here you have head, tail, head and tail, head, tail, and then here head and then tail. Then the first one is biased, so the probability of obtaining a head is 1/3. So I'll write here 1/3. Then that means this is 2/3. The next one is 1/4. Then this one has to be 3/4. 1/4, 3/4. Then the next one is 1/5. So I will write 1/5 here, and then 4/5, 1/5, 4/5, 1/5, 4/5, 1/5, 4/5, just like that. Now, to draw up the probability distribution table, remember they want us to find, it is the random variable represents the number of heads, and the heads can be no head when all of them are tails. We can have 1 head, 2 heads, 3 heads. Okay, so the probability of x is equal to 0. For no head, I can have only tails, and this is 2/3 times 3/4 times 4/5. Okay, and what does this one give us? Of course, this one can cancel, then 1 here. I can actually leave that one, but then the 4 can disappear with that. So meaning we can have our answer simplified to 2/5. And then probability of x is equal to 1. We can have probability of getting a head, then a tail, and tail. Then you can have shift this until it comes this side. So I'll have tail, then head, and then tail. And then the other one is tail, tail, and then head. You see? Now head, tail, tail, head, tail, tail is here. So we shall have 1/3 times 3/4 times 4/5. Then this other one here, tail, head, head, tail, head, and tail, not head, head. So that is the one. Then we are going to have 2/3 times 1/4, then times 4/5. And then tail, tail, head, tail, tail, head, this one here. So it is going to be 2/3 times 3/4 times 1/5. Okay, and then this one can actually simplify to 13/30, and then we can go to x is equal to 2. Then we can have probability of head, head, then tail. Then shift this t until it comes this side. We can have now the t in the middle. Then I can have the t at first here, then head, and then head. So meaning here I'm going to get head, head, tail, which is here. So that is 1/3 times 1/4 times 1/5. No, 4/5. Pardon me here, 4/5. And then the next one here, the head is 1/3. So head, tail, and then head. So we are here. So that is 1/3 times 3/4, then times 1/5. And then we have the tail, head, head, which is here. So 2/3 times 1/4 times 1/5. And then this one simplifies to 2/20. 2/20. No, sorry. This one simplifies to 3/20. And then lastly, we can get probability of x is equal to 3. That is when we only have tails. Okay, and the option we are looking for is this one here. So we have, that will be 2/3 times 3/4 times 4 over 5. And we will have it as, oh no, head 3 is here. So we're having that. And this one will be 1 over 3 times 1 over 4 times 1 over 5, which is going to give us 1 over 60. So the probability distribution table is therefore going to be, I can draw these two. Okay, can put X and then the probabilities. So here I have X and then the probability of X is equal to X. So we have 0, we have 1, we have 2, we have 3. So what are their probabilities? The probability here for X is equal to 0. We got 2 over 5. So you can put here 2 over 5. And then for X is equal to 1 is 13 over 30. 13 over 30. And then the next one is 3 over 20, and then 1 over 60. So that is that. And next they are saying Harry has 2 other coins, each of which is biased so that the probability of obtaining a head when it is thrown is P. He throws all 5 coins at the same time. The random variable y is the number of heads that he obtains. Given that probability of y is equal to 0 is equal to 6 times the probability of y is equal to 5, find the value of P. Now, if we are having the probability of obtaining a head as a P, so that means the probability of obtaining a tail is going to be 1 minus P, okay? Because when you add them, they should give you a 1. Now, we are having the probability of y is equal to 0. That means you don't have any head, all of them are tails. So you have tail, tail, tail. The first one will be gone. And then next we have a tail that is now tail, tail, and then tail. Okay, so that is that. There are 6 of them. In fact, they are supposed to be 5. They are supposed to be 5. This is 1, 2, 3. The first ones we have, and then he has other 2, so it has to be 5 here. Okay, then remember for the other one we have, if I can refer you here, so the probability of obtaining the tail here is 2 over 3, 3 over 4, then 4 over 5. Okay, so when I come to this one here, I will say 2 over 3 times 2 over, which is 3 over 4, then times 4 over 5. Now times here, these ones we are getting no heads, so it is 1 minus P, then again times 1 minus P. Okay, already this one we got it as 2 over 5, then times 1 minus P squared. And then how about probability of y is equal to 5? So here that means we are having 5 heads. Okay, 5 heads. 1, 2, 3, and 4, then 5. All of them are showing us heads. So remember, for the first one, the probability of obtaining a head was 1/3. Then for the next one is 1/4, and then this one is 1 over 5. Now here we have P and then P. So meaning we shall have P squared out of 60. Okay, then from there we can now substitute in the equation given. The equation given is this one here. So probability of x is equal to 0. We have seen it is 2 over 5. Then into 1 minus p squared. Then I will equate to 6 times p squared over 60. Okay. Then from there, of course, I'm going to simplify this. 6 goes into here 10 times. So I have 2 over 5 into 1 minus p squared, which is equal to p squared over 10. When we cross multiply, we can have 20 here into 20 here into 1 minus p squared, then is equal to 5p squared. I can divide all through by 5. That means here I can have 4 into 1 minus p. You can open these brackets, okay? You can open the brackets and you simplify that. But I can use a difference of 2 squares. This one here is the same as 2 into 1 minus p squared minus p squared, which is equal to 0. And since we know that for difference of 2 squares, a squared minus b squared is equal to a plus b, then into a minus b, that means we can have this 2 minus 2p. That is when I multiply here. Then I add the p, which comes from here. Then 2 minus 2p, then subtract p. This will be equal to 0. And this will be 2 minus p in here. Then this one here is going to be 2 minus 3p. So equating all of these to 0, p can be equal to 2. And also here, p can be equal to 2 over 3. But since p is a probability, it cannot be a negative, okay? So probability here, our p is going to be equal to 2 out of 3. Simple as that. Question 7. The 8 digits 1, 2, 2, 3, 4, 4, 4, 5 are arranged in a line. How many different arrangements are there of these 8 digits? So here we shall have 8 factorial because there are 8 of them. Then divide by those that are repeating. There are 2 2's. So I'll write 2 factorial. Okay. Then times there are 3 4's. Then I'll multiply this one by 3 factorial. And then we put this in the calculator. What do we get? 8 factorial. Then divide by 2 factorial times 3 factorial. We have 3360. 3360. That is that. Then next, find the number of different arrangements of the 8 digits in which there is a 2 at the beginning, a 2 at the end, and the 3 4's are not all together. Okay, now I'm going to pick my sample space from here. There are 8 digits. So 1, 2, 3, 4, 5, 6, 7, 8. I put a 2 at the end here, a 2 at the end here, then I kill those positions. Okay, so I'm going to look at 2's at each end. Okay, and no other restriction. That is going to be my sample space from which I'm picking. Okay, and no other restriction. Now here, since 2 2's are killed, now we are remaining with 6 digits. 8 minus 2, you get 6. So I will arrange them in here 6 factorial ways, but in there we have 3 4's. Okay, there are 3 4's, so which are repeating. So we are going to say divide by 3 factorial. Okay, then the next one I'm going to consider, they are saying and the 3 4's are not all together. Now me, I'm going to consider when they are together. Okay, then after I subtract, because when you are arranging here, the 4's can all be together. Okay, or when they are spaced. So it is easier to find when the 4's are together there. Then after you can subtract. So I'm going to consider 2's. Okay, the 2's at each end, and all the 3 4's. The 3 4's are together. All the 3 4s are together. Now, again, I have 1, 2, 3, 4, 5, 6, 7, 8. I have a 2 here, killed, and then a 2, then killed. Then I have 1, 2, 3. They are all together. So this is now one group. You take it as now one number, okay? So it can be here. It can shift like this, shifts, and then shifts like that. So meaning, since this one is 1, I'm remaining with more 3 here. So all of it together, I'm having like 4 numbers. So this will be 4 factorial, which is going to give us 24. Now that means that the 2's at each end, okay, the 2's at each end, and the 3 4's are not together. I'll consider my sample space when the 2's are at each end and no other restriction. Then I subtract when the 2's, when the 4's are all together. So what do we get here? So we shall get 6 factorial over 3 factorial, then minus 4 factorial. It gives us 96. So the answer is 96. Simple as that. Then lastly, 3 digits are selected at random from the 8 digits. These ones find the probability that the 3 digits are all different. The 3 digits are all different. Now, we can have, these are our scenarios here. Let us first outline them. I can have the 2's, okay? How many are they? They are actually 2. And then the 4's, how many are they? They are 3. And then the others. So others, actually we are talking about 1, 3, and 5. Okay, for them they are different. Then, since we need 3 digits that are all different, I can choose not 2, not 4, and then all the 3 digits are coming from here. Okay, because all of them are different. Then I can choose not 2, then a 1, 4, and then from these 3 I pick 2. Then 1, 2, then 0 here, and then 2 here. And then I choose 1, 2 here, 1, 4, and then 1 here. Okay. Now, that means here I'm going to have 2 combination 0 out of the 2. I'm picking 0. Okay. Find the probability that all the 3 digits are different. So 2 combination 0 times 3 combination 0, then times 3 combination 3. And then we are going to get 1. Then here 2 combination 0 times 3 combination 1 times 3 combination 2. This one will give us 9. Then 2 combination 1 is a 2 times 3 combination 0. That one is a 1. And then 3 combination 2. That one is a 3. So 2 times 3, that is a 6. And then 2 combination 1 times 3 combination 1, that is 2 times 3, that is 6. Then times 3 combination 1. So 6 times 3, you get 18. Then our total is going to be 1 plus 9, which is 10. Then plus 6, that is 16, plus 18, which gives us 30, 34. Then they are asking for probability. So the probability is going to be these possible outcomes. Then we divide by the sample space. So this one is going to be 34 out of what is the sample space? We are picking how many digits? 3 digits out of the 8. So without any restriction, that will be 8 combination 3. Okay. And then when we put this one in the calculator, what do we get? 34 out of 8, then combination 3. So altogether we get 17 out of 28. 17 out of 28. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.